Okay, hello. Thank you, Austin. Actually, that was a good intro, Justin, about the guns. Does anybody have a gun with them?
You want to borrow it? Or? You're in Texas, man. You all got guns.
Right. So I've got one. We're gonna use it a little later. All right. So really quick, this is me. I'm Nigel. I co-host a weekly podcast and I do training videos for a company called Pluralsight. All right. I ordered a new laptop like last week and it doesn't come until the 18th of February. I'm like, really? The 18th of February? To be fair, it's a pre-order, okay? But we live in a world, right, where we just do not want to wait for anything. Can I get a show of hands, anybody who does like waiting for stuff? Shush. Really? Somebody who does like waiting? Yeah. Yeah. So, you know, in today's world of Amazon Prime and all that kind of jazz, nobody wants to wait for anything. Some of the things that I do in my job, right, is I build infrastructure and I trash it, and I build infrastructure and I trash it. And probably up until about a year ago, I was quite a heavy user of VirtualBox on my laptop when I was on the road and also on my desktop in the office. And I would build Linux environments and do work on them, and then I'd have to tear them down and I'd have to rebuild them again. And I had this kind of good thing going where, you know, I would set off an Ubuntu server to build or a CentOS server to build, something like that. And I could go and swing some golf balls in the back garden. I could go and make some toast. I could, whatever, yeah? It would take ages to build this stuff. Then I discovered Amazon Web Services. Other public clouds exist, right? It could be Azure, Rackspace, DigitalOcean, whoever, it doesn't matter, right? And oh my goodness. Now actually, before I go on, can I, the gun is cocked, okay? I'd like a show of hands. And if you, I shouldn't point it, should I? And if you don't, you're in trouble, all right? A show of hands, who does use a public cloud service or has customers that use a public cloud service for production? So I would say that's 60% of people maybe. Who uses the public cloud service for development? Same people, maybe a couple more hands. Is there anybody who cannot or has a customer who cannot use the public cloud for compliance reasons? I reckon that's about 7 or 8 people, okay? I'm going to ask essentially the same questions for containers now. Who uses or has a customer, I'm going to shoot myself if I'm not careful, that uses containers in a production environment? 4 hands, okay? In development? Okay, about 8 hands. Right, thank you. Now, what I found out with the public cloud was I don't have to wait for anything anymore. Like, seriously. Hands up, who's built a data center or been involved in building computer rooms and stuff like that, right? I can now, and you all know this, and some people on the video may not, okay? I can build a world-class data center now in like 5 minutes. I mean, that's like tops 2 minutes, right? I can log on to Azure or Amazon Web Services or whatever, and I can create a VPC and I can click, 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 click. And I have got something that is better than anything I ever built with my own hands, right? And when I built that jazz with my own hands, you know, I'd have the scars from where I was racking servers on those rails, and it would take forever, and it would come in over budget, and oh, it was awful. Now I can build that stuff just like that, okay? And suddenly, my productivity was like, oh, awesome. Now, I don't know that I particularly expect people to show hands here, But if you're brave enough in front of your peers, is there anybody that's not quite sure what infrastructure as code is? Because just thanks for putting your hand up, Justin, okay? Now, I'm no expert on it, right? But do you remember when we first started talking about cloud, and it was like I'd be involved in conversations about cloud, and I wouldn't dare admit that I don't really know what it meant, and we're looking at cloud, and what? Well, I was kind of like that with infrastructure as code for a bit, and honestly, I'm no expert, don't get me wrong, right? But that experience of creating a VPC in Amazon Web Services, of click, 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 and I create this world-class data center, okay? I can actually kind of do it without the clicking now. So I can build infrastructure like that with this. It's just part of a cloud formation template, right, from Amazon Web Services. All the others have their equivalents, right? And I can build that data center there. Okay, so, the air conditioning units and the cable trunking and all that stuff. I can't configure that, but I couldn't give a rat's about that, to be fair. But I can build all of my networks. I can build my access control lists. I can build all of my instances, stuff like that, from a file. So gone are the days when I would, right, I'm finished with this environment, I need something clean. I set off VirtualBox building a bunch of Linux servers, take my driver outside and I swing a few balls at the net, or I go and make my lunch or something. I can't do that anymore because I can build all this stuff in like minutes, okay? And for me, right, it was absolutely revolutionary. I mean, my productivity these days compared to just a year ago, because it's only really in the last year or so I've really started taking up with public cloud, my productivity is literally shot through the roof. Mr. Lucchese?
What's the productivity that you gain from the cloud versus the container? How would you separate that or segregate?
Okay, so the question is, how do I separate the productivity I gain from using the public cloud versus using containers? I would say using the two together where appropriate, you get a double hit of productivity, right? So what I showed on the previous slide, this is Amazon Web Services stuff, okay? I can build the infrastructure, the instances, the network, stuff like that, really easy using that. Maybe I'll talk about what the container brings a few slides time. But I think using the two together, I don't know if this helps your question much, but using the two together it's that perfect storm, yeah? All right. Right. Who likes downtime? Ray, no you don't. Well, actually, to be fair, I've liked downtime in the past. It's one of the best ways to learn when stuff goes down. But generally speaking, we don't like downtime. So I'm going to say, right, public clouds and containers and all that jazz. I know, okay? But stick with me, okay? So, again, it's an Amazon Web Services diagram, but the principles are the same, right? Back in the day when I was building data centers, it took ages and it was hard work and it was lots of money and all that stuff. I worked in the financial services sector in the UK for a long time, right? Pretty much I only ever worked with 2 data centers. We never really had 3 data centers. Now, the click of a few buttons, a cloud formation template, I can effectively have 3 data centers. Now, I know within the old data centers we used to build, there were different rooms that were failure domains and stuff like that. But the thing is, right, I can build a few clicks, 3 world-class data centers, right? And then I can overlay my infrastructure across all 3 so that if I lose one, I'm still in business, right? I lose 2, effectively I'm still in business. Okay, I get that, I've lost 2/3 of my capacity and what have you. So I might not perform so well, but I'm still effectively in business. And the thing is, I'm ranting on about it now, right? But I can build it and tear it down and build it and tear it down 50 times a day if I want. Clean slate every time. It's just the business for me, okay? Now, the Tech Unplugged kind of theme and motto for this year is, and the subtitle to the talk was Life on the Bleeding Edge of Technology, okay? There are companies and people that are kicking the tires with this. So if you look closely, right, it's effectively the same high-level architecture. I've got 3 failure domains here, but instead of this one being, well, it can be any region within AWS, right, that has 3 availability zones. Instead of them being within one public cloud provider, you can spread it across on-premises and other public cloud providers if you want to, right? Now, people are doing this, kicking the tires with it. It is a little bit bleeding edge, but it's doable for certain applications and use cases today, and it's going to be, I promise you, more and more doable going forward. The big issue that people have with this right now, I'll come to you in a second, Ray, is the network. It's always the network, right? Is Tom in? Okay. It's all, but genuinely here, right, it is the network. So latency issues and network partitions tend to be the biggest problem that you have here, right? That kind of jazz is getting better. Come to you in a sec, Ray. If you are looking at something like this, you really want to be looking at technologies like Direct Connect for Amazon Web Services, Express Route for Azure, things like that. So you've got, you know, your colo data center, whatever it is, and you've got dedicated pipes into these cloud providers, then it becomes moderately doable, okay? And going forward, it'll be more and more doable. Ray.
So you replicate the storage between Amazon, Azure,
right.
and data center?
The question is, am I replicating storage between Azure and AWS, right? No, I'm not, okay? So the only things I've really used it for non-persistent things, so where I would balance web front ends and worker queues and stuff like that, not replicating. Yes?
Yeah, so I think that was probably my point too, is the time to move data and
Yeah.
restore data.
Yeah.
That's the physics, that's the network, that's the storage.
Totally.
But you can't replicate storage if you want to spend the time and effort. I mean,
Yeah?
there are products out there that can do that.
So Ray is saying there are products out there that can do that for you if you want. What I would kind of suggest is that these kind of architectures, right, tend to be for more modern applications, right? Applications that are written to leverage this kind of an architecture, yeah? So you're not going to just lift and shift your old legacy enterprise apps onto something like this. There's an amount of refactoring has to go into something like that. Okay? And again, this time we can lose on-premises, we can lose whatever, and guy in the middle still works. Brilliant. Right. Coming to your earlier question, Ray, about the container side of things, right? There's also the whole idea of container orchestration, right? So we've talked about how I can build and tear down infrastructure dead easily, but how do I do that with the application now? So quick analogy, right? I stole these slides from a Pluralsight video I did. I'll just mention that in case they're a bit upset, give them a bit of a shout out. This is the coach of an American football team here, right? And he's got a playbook and he takes a bunch of people that have different skill sets, right? I don't even know what some of these mean. I know QB is quarterback and TE is tight, WR is wide receiver, right? Ooh. Anyway, he takes a playbook and he makes them work together as a team, right? Application and container orchestration effectively let me do the same with my application. So I can take a bunch of different microservices, get the buzzwords in, right? And I can write a playbook for that, a compose file in the Docker case or whatever, and I can deploy it onto my infrastructure. Man, you can't, the color's gone mental there, but these are our 3 different hosts. Can deploy my containers and my services across our 3 different nodes, get them all to talk to each other, all configured in a file. Again, I can tear it down, I can build it back up 50 times a day if I want to at the click of a button. Right. Oh, yeah, I can get rid of it. That's what I'm saying, I can do it again. Beyond content, Ray. Yeah?
So, is there persistent storage in this environment?
Not necessarily in that environment, but there can be, because you can mount volumes into containers. You can destroy a container and the volume data doesn't go away.
Volumes or lines, it could be object storage or,
Could be. In the container world, volume doesn't necessarily mean what the same as you might imagine it to mean. Maybe it's one for later on, okay? I'm watching the clock, right? You, tell me what's coming beyond containers.
Unikernels, man.
All right. Hands up anybody who knows what unikernels are. Oh, I like it. So there's a moderately good balance. I, count the people who didn't put their hands up that really do know what it is. So in case you don't know unikernels, a picture speaks 1,000 words, right? This is the old traditional model. Sir, would you be my helper?
Sure.
I want you to stand here on this square, and I want you to, you've got 4 bullets in there. I want you to shoot down. You've got to get a bit closer because you've got to hit on this one, right?
Well, I'm native. I'm from here.
Okay.
So.
Yeah, but that doesn't fire straight. I want you to take down one of the virtual machines.
One of the virtual machines?
Yeah. Right, bingo. Okay, hang on to that for the time being. Right. So, I'm going to get up on here for a minute. You can sit down for a second. I'll give you a shout. Appreciate that. Right, so this is the traditional hypervisor model, okay? Huge, okay? There's a lot of waste. We can get rid of stuff. I'm going to go Minority Report here. So we can, I better go this side. Sorry, Enrico. Get rid of the top layer, get rid of that layer. Okay, right. Oh, sorry. We replaced the hypervisor with an operating system, and we're going to build containers here. Shrink down our applications, run them inside of containers. Next bullet, can you take down one of my containers, please? Oh, you need to cock it, I think. Right at the back, the yellow button. Yeah, on the top of the handle. Oh, my bad. No, my bad.
No, the orange one.
Yeah. Oh, did I say yellow? My bad. Okay, not a bad shot, okay? A bit harder to take it down, smaller attack surface, okay, right? In this model, our application makes system calls and things down to a shared kernel and shared operating system underneath. Point is, that's still a fully fledged operating system, okay? It's still got a bunch of stuff in there that we don't need. In come unikernels, right? What animation did I do here? Right, so we replaced the operating system for a hypervisor. Bit skinnier than an operating system, okay? Smaller attack surface. Lose the containers. Right. These unikernel solutions, right, are so small, I couldn't even write unikernel on them, right? And I'm not kidding you, right? You can spin up a web server and a unikernel, so the operating system code effectively and the web server, less than 5 megabytes, 2 or 3 megabytes probably, okay? We'd refactor our apps a little bit as well, make them even smaller. So with the gun, I am challenging you now to take down my tiny attack surface unikernel, and I'm going to get out of the way. You have 2 bullets left. I don't know if that one's... Oh, sorry, man. One more. Have another go. I'm being generous here. Right, so... He's an awesome shot. He's a native Texan. Unikernels have triumphed, all right? Because the attack surface is so small. Now, the thing is, right, how do they work, okay? So, Yoop is probably going to go into more detail later this afternoon. I'd put him as the resident unikernel expert, right? But you write an application and you only hook in the kernel components that you need, right? So, if your application, I'm not going to offend you here, Ray, but doesn't need to use persistent storage, right? You don't include any storage drivers. It doesn't use IPv4. Leave all of that jazz out, right? You link in the libraries and the modules that you need and nothing else. And you can run a web server unikernel that's like megabytes. Now then, okay. Unikernels and security, okay. Enrico, please come to the front. Come on. And you too, Arjan, it's your event, right? The clock is ticking, so in your own time, gentlemen, on the stage, please. Both of you on the stage. Right, so Arjan, you're not allowed to look at the slide, right? You're not allowed to look at the slide. We're going to do this, right? Arjan is the big bully, okay? Turn around, right? So unikernels and security is all about wedgies. What we're going to do is I'm going to tell Enrico a secret, and Arjan is going to give him a wedgie and force the secret out of him. I'm just kidding you. Have a seat, right? So the idea here about small attack surfaces is, right, and I know you all get this, but is that if you're not wearing your underpants, nobody can give you a wedgie and can convince you to let them in and get your data. No, but I'm deadly serious, right? I did a Pluralsight course a while ago, my first course on Docker, right? And I made the statement that with our applications, if we could go commando, so run our applications without an operating system, we absolutely would. I love operating systems, right? I'm a bit of an operating system fan. But at the end of the day, it's overhead and it's attack surface, and if we could do it without it, we totally would, right? So unikernels and security is all about wedgies. Now, let me just compare legacy virtualization with container virtualization versus unikernels, and then I'm going to wrap up. So back in the day, right, this was our operating system. It had all the bells and whistles. It did everything, right? But, I mean, honestly, if you want to take that guy down, you're an attacker, that's dead easy, right? I wanted a guy with no clothes on, but try searching for that in a public hotel. It's not good. So I think container virtualization stripped out a lot of the unnecessary stuff. Doesn't need hair, doesn't need clothes, right? Don't have them, right? If container virtualization was stripping down the operating system and the application, I would say unikernel virtualization is genetically engineering it, right? So let's just say we want to write an application that is some kind of sentry, right? And it's got to be able to watch out for attackers, for signs of intrusion, and when it sees it, it pushes a button, right? So you don't need a full man or woman there with legs and hair and all that jazz, because all it has to do is look and listen and hit a button when the intruder's found. So you can literally just put in the things that you need: a head, an eye, an ear to watch out for the threat, an arm, and a single finger to hit the button. No underpants there, no wedgies even possible. And look, right, it's way smaller, so we can pack them in more densely. And yeah, we don't really even need to do that because I want to leave time for questions. But I was just going to say, if virtualization and containers built cars, it would look like this. It would have all the mod cons and trimmings and stuff. But if unikernels built a car, it would look more like that: faster, leaner, more suited to what it was doing. Any questions? But I honestly don't have any. No questions? Okay, no questions. I'm around all day, right? Thank you. Can I have my gun back? Thank you, I appreciate that.